Welcome to another video on using PixInsight for astrophoto editing. This one is going to be a little bit of a departure because we're not going to look at PixInsight in itself, but consider imaging workflows, because half the battle with PixInsight or any other photo editor is deciding what you're going to do and how you're going to do it. And the actual details of the separate steps can be a set of follow-on videos. Without further ado, let's look and see what we've got to do. Before anything, what are we trying to achieve? What makes a good astropic? And I've listed a few things depending on the subject. So for a nebula, I want strong but unsaturated colour, detailed and with good colour variation. Make it interesting, in other words. For stars, I don't want them not too big, not too small, but just right, avoiding just simple white dots and having some real colour in them. And that's quite challenging at times. With backgrounds, I want them not to be intrusive. I want them dark but not black. I want them noise-free but not plastic, and without any obvious colour gradients across them. And lastly, for galaxies, I want to show structure of the galaxies. I want to see some colour in it. I want to see its fullest extent, and all that without washing out the central core. So there are a couple of pointers as to what I'm looking for in a good astro picture. Let's have a look at some. This is a diverse group of pictures. On the left you have the Jellyfish Nebula, which is imaged in narrowband with 3 filters: sulfur, oxygen and hydrogen, and we are creating what we call a false colour image, where the hydrogen is assigned to green, the oxygen is assigned to blue and the sulfur is assigned to red. Top right we have M101, which is a famous large galaxy in the northern hemisphere, and here we're trying to do what appears to be natural colour. It's slightly enhanced in so much that we've boosted the colour saturation, but the colours are real in so much that they haven't been deliberately distorted. And you'll notice that the stars are colourful around the perimeter, and you can still see some of the fainter swirls around the outside of the galaxy, which are often missed in exposures of too short a duration. And in the bottom right hand corner, with a fairly recent acquisition, which is a colour CMOS camera, I've done the Heart and Soul Nebula, which, although it's a colour camera, I've actually put a special type of narrowband filter on it. And here I've tried to capture the nebulosity within the nebula, but unlike the one on the left, this is in more realistic colour in so much that the hydrogen is reddish and the oxygen is bluish. But it's my first attempt at doing a colour image with a colour camera but capturing nebulosity. One of the things that you soon appreciate with doing astro pictures is that everything is different. Those differences are not just about the subject, they can also be about the equipment. So here on the left is a monochrome CCD with a filter wheel, which has both narrowband and standard red, green, blue filters in it. Top right we have the latest colour CMOS cameras, which in this one it's refrigerated, so it gives a better result than using a digital SLR or mirrorless camera. And in the bottom right is a standard cheap plastic EOS camera stuck on the back of a telescope, which, although it's using a CMOS sensor, which is colour, it's also unrefrigerated, so it tends to be noisier over long exposures. So when you put all these things together, there's some key takeaways. And that is, there's no one do-it-all workflow. The camera system changes the workflow. Each image usually requires a modified approach depending on its content. Elements within the image often require different types of treatment. So selective processing, which what that is implying, means you duplicate the task, you normally have to use masking, and sharpening and reducing noise are two sides of the same coin being applied to two different parts of the image. And lastly, it takes time. There are no shortcuts, and I normally take the best part of a weekend to process an image to a good standard. So let's look at a few example images and the sort of challenges that they give us. This first one is taken with a CMOS colour camera, and the first thing to do is think about raw conversion and what method you're going to use to do the raw conversion. And then the last thing is, with the raw conversion, is colour balance and light pollution. So did you use a light pollution filter? Have you got heavy light pollution where you are? How are you going to get rid of it without destroying subtle detail? The next thing is how to stretch it to show the nebulosity without bloating the stars into big white blobs. And then next is how to reduce the noise on the background, because stretching emphasizes noise, and reducing the noise on the background without necessarily making it look plastic. And then additional work if we're using selective filters. In this particular case, I used a duo narrowband filter which passes red and blue wavelengths, as well as a light pollution filter at a different time, and I used one for the stars and one for the nebula, and then pulled the two together. So that's one example. The next example is more familiar. This is M45, or Pleiades, or the Subaru, or the Seven Sisters, or whatever you wish to call it, and this is in natural colour. The challenge of this subject is that it has an incredibly high dynamic range. The central stars are incredibly intense compared to the faint nebulosity and gas in the surrounding background. Now, this has its own challenges. These were done with a separate LRGB filter. I used all the filters and all the information to create luminance information in order to extract this very faint detail without excessive noise. I had to colour balance the red, green and blue, so I've got a wide range of colour in the stars without being excessive. I've got natural colour in the blue rather than too intense, and yet the colour goes all the way to the very core by using several sets of exposures at different lengths, so I avoid clipping the stars at all costs. And then finally I have to combine the luminance file that has all the detail and all the wispiness of the cloud and so forth with a nice diffuse, soft and colourful colour image which has all the stars and the blue nebulosity information, and pulling them all together, and then some fine tuning at the end. So a very different workflow to the previous image. If we move on again, this is what they would call a false colour narrowband image of the Rosetta Nebula. This would typically be red if you just used a natural colour filter. In this case I have 3 narrowband filters and red, green and blue filters, and what I've tried to do is capture all the nebulosity using the narrowband filters and the star colour using the red, green and blue filters, and pulling the two together. So one of the key decisions I had to make was whether to remove the stars before stretching, because while the hydrogen alpha, which is this bit around here, is very intense, the sulfur, which is also around here, and the oxygen, which is in the middle, is far less intense. And so if you just stretched each of the colour channels to the same extent, you'd have a red image. So you have to do things in order to get the colour channels more balanced, and that typically can bloat stars because you involve stretching some of the dimmer channels by more. So one thing to do is either minimise or remove the stars altogether, stretch and get just a nebula only image, and then plonk the stars back on top. And what to use for luminance? If you take the luminance information, sometimes that can be a bit of a washout, and it sometimes helps to use the hydrogen alpha information, which has more detail within it. So again, you have to look at the data and decide which is going to make better information to use for the purpose. And in this case, I think I took 20 hours of luminance information and never used it in the end. I just used RGB for the stars and the 3 narrowbands for the nebula. And then lastly, when you do a false colour image like this one, the stars are never normally neutral or accurate, and so there are ways of neutralising the stars and just making them either white or grey, but I like to try and put some real colour back in them. So again, I use the red, green, blue information, only an hour's worth of exposure, and pop the star colour back in using a star mask. And then lastly, these are the sorts of workflows that result from these images. Now, they're not meant to be readable, it's just giving you an idea of what's going on behind the scenes. So each of these corresponds to a different image, and each of the vertical paths is typically what's happening to a part of the image. So it might be the nebula, or the stars, or the colour, or the luminance. This one over the right hand side is for a comet. It has more columns because you process the comet head and its diffuse tail separately to the stars that surround it, because they're moving in different directions over the exposure plan. and so forth. And the idea here is just to show that things get very complicated. Don't panic, as Mr. Adams used to say. It does look complicated, but just take a few things in mind. Even with simple photo editing, if you actually consider the number of steps that you do just doing ordinary Photoshop or Affinity Photo, you will do dozens and dozens of different steps to get your picture just right. And all that I'm doing is documenting those steps, so it looks a little bit more complicated than it really is. But also, the act of actually writing down a workflow and planning the image processing makes you more aware of which tool to use, on what and when. So obviously later videos are going to look at the individual tools and how to apply them with little tips and tricks along the way. But before you just blindly go in and start manipulating images, it's worthwhile having a plan. So let's have a look at a little bit more in the way of planning. We are going to consider the high-level requirements of 5 images. The first of which is a loose cluster called Caroline's Rose, and this was taken with a CMOS colour camera. It's nice and easy because there's only one element in there, which is stars. There's no nebula in there or galaxies. We're going to neutralise the background and reduce the background noise. We can colour balance the stars and stretch them without clipping them and forming white dots. It's a good idea to increase the saturation of the stars a little as well, and then decrease the colour saturation of the background so that it hasn't got any weird gradients or strange colours. And that's probably the most basic workflow that you can do. But even in that workflow, there will be masks used to allow you to be selective with sharpening and noise reduction and so forth. The second image also comes from a colour camera. This is of the Heart Nebula. Now, I used an ordinary light pollution filter, but I also used narrowband filter as well in order to pick up the nebulosity and reject more of the light pollution. So the approach here is to process the nebula and the stars separately, because they require very different treatments. The stars don't need much stretching, they need natural colour. The nebula is very dim in comparison to the stars and needs a lot of stretching. So the first thing to do is balance the nebula colour and the background, shrink the star sizes to avoid bloating, because the next stage we're going to do is a lot of stretching to make the nebula pop out. On the stars, we're going to colour balance the stars and stretch without clipping, and again increase the saturation of the stars and blur slightly. And the reason we're blurring it is on the final step we're going to combine the colour image of the nebula with just the colour information from the processed star image, and that way it just gives us, you know, a range of blue and orangey stars and red stars occasionally on a natural colour image. Now the next one is the same subject but a very different treatment. So this is part of the Heart and Soul Nebula, the same camera, same filters, but here we've taken a more advanced view because I wanted to show the differing nebulosity in the core of the Heart Nebula, because there's quite a bit of oxygen and sulfur in here as well as hydrogen. So what we've done here is we've split out the different colour channels so we can balance them more effectively, because typically in many astro pictures the hydrogen alpha nebulosity dominates the image and the sulfur and the oxygen are typically much dimmer. Not in all cases, but in most. So what I'm doing here is I'm separating out the luminance for the information so I can get nice sharp details around these cloud structures. I'm going to process the narrowband and the stars separately, as I did before, but this time I'm going to stretch the colour image. I'm going to extract the narrowband into separate red, green and blue files to do that, because that's the easiest way. And sometimes it's a good idea to take the stars out or reduce their size as well, because stretching typically bloats stars at the same time. I'm going to decrease the colour saturation of the background because the stretching process will make it go wild. This one actually has a lot of faint nebulosity all around the perimeter. So one of the tricks here is to choose some part of the image which has no nebulosity whatsoever, and there's only a little bit which is up here. All down here and all around here there is faint hydrogen alpha. And then on the stars side we're going to colour balance the stars and stretch without clipping as before, increase the saturation and blur slightly, so very similar to the last image, and then again combine the two together. But when you compare the two images, very different approach, by splitting out the channels, that gives you more effective chance of balancing the intensity of the different colour elements of the image. And this is also very similar to what you do with true narrowband files of a monochrome camera. So this is LRGB, luminance red, green and blue filters on a monochrome camera, plus hydrogen and O3 as well. I think there might even be a bit of sulfur if I remember rightly. So this is part of the Veil Nebula. It's in false colour, and we're processing the narrowband and the LRGB for stars separately as before. And what we're going to do is extract the luminance information from all the narrowband and process it for detail in brighter areas and suppress noise in the background. And then we're going to blend the hydrogen alpha and oxygen, and I think a bit of sulfur, into the red, green and blue channels, and balance the intensity between the channels, and then combine them and blend them so that we get a range of colours, which makes it more interesting. We're going to reduce the noise and increase the colour saturation, and then decrease the colour saturation of the nebula background. So here you've got very faint tendrils of different emissions. So again, finding parts of the sky that are truly neutral and without nebulosity is quite tricky. And on the star side, again, as before, we're going to colour balance the stars and stretch without clipping, increase the saturation of stars and blur slightly, and then combine the two together so you have fairly regularly coloured stars on top of a false colour image. So that's quite a complicated one. And lastly, it looks simple but it's actually the most complicated of the lot, is a comet. And the reason it's complicated is that during the stacking process, the stars which you typically are tracking on are stationary between images, but the comet is moving in a different direction. And on this picture, the overall image is quite a bit larger than what you see here, and the comet moved in this direction diagonally downwards between each frame. So here I had to have completely different stacks which were designed to show the stars in one with no nebulosity around the comet head, and then an image just of the comet head with its tail with no stars. That was done by using the rejection algorithms of the stacking program, because as it moves the stars appear in different places and the rejection algorithm thinks it's noise and gets rid of it. Then I had to process all this stuff separately in different channels, get the colour balances of each. So basically at the end of the day I had a star image without a comet and a tail, and I had a comet and a tail without any stars, and then put the two together. Now that is a very complicated one, and that bizarrely is this one here on the right hand side. So what I've just described is what I did here, and these are all the different little steps: colour calibration, noise reduction and so forth. What I wanted to do is just give you a flavour of the sorts of things that you have to consider when you're looking at a workflow. We're going to be using some example images to highlight PixInsight tools in later videos, but bear in mind that you don't necessarily follow them blindly in the same order for every image. It really depends on the content, the equipment and what you want to accomplish with the image processing. Anyway, thank you for watching and see you next time.